Jeff Williams is a veteran application security expert who founded and led OWASP, AppSec Security, and Contrast Security. Jeff also created several highly successful open source projects, including JBomb, JOT, OWASP Top 10, WebGoat, ESAPI, ASVS, and more. Jeff is an advisor to NIST, CISA, PCI Council, OASIS, Seraph, OWASP Cyclone DX, OWASP Foundation, and Eclipse Foundation, and advises many companies and agencies on application security. Jeff joins us to explain runtime protection, including both IAST and RASP. He helps us understand the benefits and differences from classic AppSec tools, and even helps change my mind about the usefulness of IAST. We hope you enjoy this conversation with Jeff Williams.
Are you struggling to measure the effectiveness of your secure code training? You're not alone. That's why we're proud to share that on average, Security Journey learners increase their knowledge an average of 33% and as much as 85%. Our diverse training content satisfies a variety of adult learning styles, from conversational training videos to hands-on secure coding activities, ensuring that learners are engaged no matter their learning style. Visit securityjourney.com to try our training today.
Hey folks, welcome to another episode of the Application Security Podcast. This is Chris Romeo. I'm the CEO of Curve Ventures, joined by my good friend, Robert Hurlbut. Hey, Robert.
Hey, Chris. Yeah, Robert Hurlbut, and I'm a principal application security architect and threat modeling lead at Acquia, and definitely very glad to be here today as well.
Yeah, and our guest today is a well-known name and face within the industry of application security. Also somebody that I used to work with back when the years started with a 19 on them. That's a little bit of a picture of how old we are now. Now, I have a lot more gray hair than Jeff Williams does, but that's
not
okay.
Really. It's just shorter.
Well, so we normally do security origin stories, but this is Jeff's second visit to the podcast. We did an episode with him back in November 2018. Called The History of OWASP. So if you want to hear the details of Jeff's origin story, you can go there. And we're going to talk about runtime security today. But Jeff, you had kind of given us this note about 1.7 million issue backlog in Veracode. And without any other details, I was like, okay, let's start here. I want to unpack. Tell us the story behind this backlog.
Well, so that story is pretty easy. You could ask just about any CISO or AppSec lead in any company about their AppSec backlog, and the answer you get is not going to be fun. It's going to be hundreds of thousands of issues, or in this case, millions of issues that those tools have identified, and they just get put into some tracker, right? Sometimes it's Jira, sometimes it's an ASPM, sometimes it's some spreadsheet or something, but those issues just sit there. They're not really getting triaged or fixed because there's so much human work associated with doing that. So that's kind of the pattern that happens. And if you back up, it's kind of obvious that it would happen, right? If you use noisy tools, they're going to generate a big pile of stuff that needs to be triaged, and nobody has the resources to do it. So you're going to be generating this giant backlog, and it's just going to sit there. And I think some companies count that as success. I don't think that works. So that's why I'm still working in this industry, is because it is broken.
What's the root of that problem? Because I remember in the past when tools were judged by the volume of findings that they could create. But it doesn't seem like we grew out of that though. Like it's still the prominent way that people think about tools, even though it does result in a lot of pain for the people that use the tools.
I think there's two things. The first is just fundamentally SAST and DAST tools aren't that accurate. They're a little different. Like DAST tools tend to miss a lot of stuff that's real. SAST tools tend to generate a lot of false positives. But the tools themselves are inaccurate because they don't have enough context. So just looking at the source code, you really don't know what that application is doing or how it works. And the same thing with DAST, just looking at HTTP responses, it's impossible to really see what's going on inside the running code. So you just miss a lot. That means you're going to generate both over identifying things and under identifying things. And anytime your tools aren't accurate, you have to have people involved And there's just not enough people to do that. So it doesn't scale.
Yeah. Why do you think? Oh, sorry.
Go
Go ahead. Finish your thought.
Well, I think the other thing is that people tend to evaluate AppSec tools on one app. And they look at the results and they're like, oh, those are okay. There's some false positives, but I could handle it. And they don't think about what happens when it scales to hundreds or thousands or tens of thousands of applications, and the absolute unmanageability of that when it all has to go through a very small number of AppSec experts. So they don't think about the scaling. They just think about one app at a time, which is really a pretty poor way to think about your AppSec program.
And you're someone who's been around AppSec since the beginning of AppSec, like when it became a thing back in the late 90s. Why do you think the SAST and DAST technologies that we haven't gotten better? Why do we still have the noise problem that exists in this industry? Why hasn't somebody just come up with something better and squash those things completely?
It's actually a really hard problem. And I make this analogy all the time. I say, like, evaluating the security of source code is pretty similar to evaluating a contract for loopholes. And it's written in a customized language. There's terms of art in there. There's things that are defined externally. And you really need expertise to do that job. You need to see it kind of in action. And it's the same problem with source code. There's millions of lines of code in a specialized language that has dependencies on stuff that you don't understand. And it's really complicated to identify. I did 15 years doing pen testing and code review. And so I was like right there in the code looking at problems. And there's just tons of things that you can't really figure out, either statically or with a traditional dynamic tool. And our insight was like the only way to figure it out is to actually watch that code as it's running. Then everything's assembled, everything's in context, and so there's a bunch of advantages. But like to your point, SAST tools have reached the limit of their evolution. Like they're not going to get better because there's no more information there to get better with. It's a lack of context that's the problem.
Well, let's take a look at that. What is runtime security? I know you were talking about it and around it, but let's dive in. And how does it work, and how does it compare to some of these other methods?
So runtime security it's really two things. One is it's a technical approach to monitoring code as it runs and identifying both vulnerabilities and attacks and other interesting attributes of an application that you want to detect. It really applies to all the different pieces of application security. So you can do runtime testing for security. You can do runtime software composition analysis against libraries. You do runtime protection of applications. And you can even do runtime observability that just identifies how your application works from a security perspective. But it sort of covers the whole gamut. It's just a different approach than using source code or the running application or manifests or repos or those kinds of things to generate it. The other piece of it, so that's like the technical aspect of it, but the other piece of it is really more how you think about your AppSec program. And building an AppSec program based on runtime data is different because it is much more accurate. It works in real time and it's very scalable. So you can really empower development teams to do their own security work in a way that people talk about a lot when they say shift left and all this, but static and dynamic are really not very amenable to pushing onto development teams to do their own security because of the inaccuracy problems. WAFs too.
So in your AppSec program that you're building here, are you using SAST, DAST, and WAF at all? Or are you just throwing them out and saying we shouldn't even, these technologies don't even belong in our pipelines?
So there's a great article I read recently about security as trying to cover a square box with round stickers. I don't know if you saw it. I'll send you a link and we can add to the show notes. But there's always going to be corner cases and like languages that IAST doesn't support yet. IAST supports a pretty broad range. of languages now, but that doesn't do COBOL, it doesn't do C and C++. So there's like corner cases. So I'm never going to say there's no role for traditional SAST. I do think that DAST is easily replaced by IAST. In fact, IAST is a better DAST. It is DAST because it works at runtime. It has an impeller and an analysis engine. The pieces moved around a little bit, but really it's just DAST. With positioned in a better place to get more data. So I can see the need for DAST phasing out. And WAFs overlap with RASP a good bit. RASP provide really high assurance protection from within the running application because it can be more accurate, has a lot more context. But there's things that WAFs do that RASP can't, like WAFs can look at SSL and things that are upstream from the application and help out there. They also kind of filter out lots of low-hanging fruit, obvious attack stuff. And you can do it at your load balancer or your, in your cloud infrastructure somewhere. Maybe it's in your CDN. And so I think there's a reasonable role for a kind of a cloud WAF there. But if you want real protection against things like unsafety serialization and XXZ and things that are hard for WAFs to see, like how's a WAF going to look inside your serialized objects for attacks? Probably not. So you really need that protection inside the running application.
Yeah.
Are there any?
So hopefully that explains it. Like I think of runtime security as covering most of the box with a big round sticker that covers testing, SCA, protection, and observability. And then there's some corners in the box where there's other things that you need to do.
What about performance, though, when these are running along with the code, inside the code, and so forth? Are there any issues there and impact as well?
Yeah, it's a great question and something we get from customers all the time. And IAST and RASP have both come a really long way over the last 8 years. RASP, for instance, is super fast. It takes about 1% of your CPU and memory and so on. So it's actually really efficient that way. And I want you to just think about on the attack side, if you think detecting attacks is important, there's going to be a performance hit somewhere. It might be in your WAF. Typical WAF takes about a millisecond or two to process a request. And RASP takes much less than that, probably about 1/10 of that for normal traffic. So I think the impact is negligible. And in a test environment, IAST is really fast too. It's actually a little slower than RASP because detecting vulnerabilities is actually harder than detecting attacks that are exploiting vulnerabilities. If someone's exploiting it, you have more information so you can make the judgment quicker. But IAST is really fast. You'll never notice it as part of your normal test cycle. You can finish, and you can finish all your security testing during the build. A SAST run might take hours. A DAST run might take more than hours, days.
Years.
And you can't do that inside a pipeline when your SLA is 15 minutes. So with IAST, you can get much higher quality results. Finish within your normal pipeline. You don't have to start some async process. So at the end of the build, you can test to see whether there were new vulnerabilities found. And you can report back to the developers immediately. They don't have to wait some amount of time to get their findings and triage them.
Let's unpack this IAST example a little bit because I wanna check some of the things I think I know about IAST and get your perspective on this. You were a part of the conversation that we had going on LinkedIn about why DAST doesn't make any sense anymore, and it was a fun conversation, and it was probably the most hate mail I've collected in the last number of years. That's okay. Because I think it's
all DAST vendors, I assume.
There were a few vendors who wanted to argue with me about the viability of the DAST technology. So one of the reasons that when I thought about DAST and I decided, hey, I'm just not recommending this anymore. It's not going to be a part of the stack that I think people should use. There's a couple different reasons, but one of the big ones was it just doesn't work in a DevOps world. And if in the way software is being built now, if something doesn't work in a DevOps world, you can't. It's not viable to use it, in my mind. And so, I guess one of the things that I thought I knew about. I thought IAST would suffer from the same problem, but I'd love to hear, Jeff, your perspective on why does IAST work at DevOps speed?
Oh, man. I mean, IAST is really ideal for DevOps. And the reason is it turns your normal test cases into security tests. So everything that you do to test your application, whether it's manual testing or automated testing, IAST is in the background adding security tests to those things. So there's literally nothing that you have to change about the way that you build, test, or deploy code to get value from IAST. The other thing is it doesn't require any security expertise. Like DAST really does. If you want to get a DAST tool to crawl an app and fill out forms and properly traverse the application, you got to teach it a lot of stuff. IAST really doesn't have that. Anybody could use this. You and Robert and any developer out there could find complex data flow vulnerabilities inside an application because IAST doesn't require vulnerabilities to be exploited. So just by typing in the word Jeff into a form field, that data and all the other data in that HTTP request all get tracked in parallel through the application. If any of that data shows up in a SQL query, IAST checks back along that path to see like, hey, was this data properly escaped or parameterized so that SQL injection would be prevented? And if it is, then nothing happens. But if it hasn't been, if the right defense isn't there, then we report a vulnerability with all the details, the HTTP request, the lines of code, the exact data flow. You can see the actual SQL query that was, goes to the database. So it's much richer finding for developers, and it appears instantly, like within seconds of just a developer, testing their own code locally, even before they check it in. They can use IAST when they run that code locally, get findings, fix it, and check in clean.
So are you using the same detection and rule technology with IAST that you are with RASP, or are there any differences between those two?
There are some differences. And let me talk about how those two things fit together, because they're really two sides of the same coin. So the way I think about it, the real problem is that in your stack, there are a bunch of overpowerful methods. OP, my kids would say. And those methods are the core of vulnerabilities. When developers don't take the proper security precautions before invoking those methods, that's when they introduce vulnerabilities. When attackers can make their attacks reach those methods, that's where there's a problem. So IAST and RASP, at the core, what they do is they wrap those methods with what I'll call trust boundary that looks at the data that's coming in and makes decisions based on it. So it's actually pretty straightforward checks. If untrusted data makes it to a method that, say, sends data to the database or calls a runtime process or evaluates an expression or whatever, if untrusted data makes it to those things without being properly escaped or parameterized, then that trust boundary flags it and sends an instant notification to the developer. So it's across the whole stack that this works. And it's really, if you think about non-bypassable mechanisms, going back to the Orange Book, that's really what we're doing is we're establishing trust boundaries around the things that are abused by most vulnerabilities. Same thing for RASP, same trust boundary, except now that trust boundary goes one step further. It says, hey, is that data that just came into this method, like into the execute query method, does that data modify the meaning of the query? If it does, then we know that it's an exploit attempt, because no untrusted data should ever modify the meaning of your queries. That's the definition of SQL injection. And that's what that trust boundary enforces. So by rolling this out, you can eliminate whole classes of vulnerabilities, command injection, SQL injection, XXC, XSS, a bunch of different path traversal, a bunch of different classes of vulnerabilities. Make sense?
Yeah, I'm tracking with you. I mean, I see the back on the IAST side, as far as being able to use your existing test cases, you're not creating, you don't have a security test suite and a functional test suite. You have a test suite that's being run, that you're already running in the pipeline. It's already part of your pipeline process. So I'll basically, you're saying with IAST, all I'm doing is I'm adding an agent to the runtime that's being tested against in the pipeline. It's alerting on that. So it's causing maybe a tiny performance difference, but it's not taking me minutes or hours to days to weeks, which DAST scans could take weeks sometimes, like if it's looping and out of control. So it sounds like it is a better mousetrap. It is a DevOps friendly way to have to still use the technology.
And what we're seeing, the results that we're seeing, and we measure this super carefully, is really positive for this approach, including in DevOps organizations. What we see, the first thing we see is that you find a lot of vulnerabilities with very few false positives. The second thing we see is that those vulnerabilities are getting fixed. And we believe this is because we're giving instant feedback. So our MTTR across hundreds of thousands of applications is like 3 days. It's not 290 days like static or 315 days like DAST. MTTR goes way down. And what that does is it reduces the backlog. So we see the line of new vulnerabilities getting discovered, and then the line of vulnerabilities being remediated catches up. And we automatically detect that those vulnerabilities have been fixed. So once you catch up to that line, then the question is how many new vulnerabilities are we introducing? What rate are they coming in at? And we're seeing that go down too. So a typical project will introduce 4 new vulnerabilities per month, per project, that's a decent amount. They pile up pretty quickly if you're not staying on top of it. With IAST, we see that rate go down. So we're seeing 0.9 new vulnerabilities per month per app after you've been using IAST for a while. So you get to this really healthy place where you've cut your rate of new vulnerabilities dramatically, your MTTR is really fast, and you've worked off your backlog. That's where we want companies to get.
What about reachability? I've heard that mentioned in the context of runtime security, and our listeners know I've talked about this a number of times. I was an early adopter of RASP technology when I just looked at it as a small startup and said, this is gold because I don't have to have all the different layers that we weren't really ready for as a small startup. I could have the one protection device that's going to sit inside of the runtime and grab a hold of those things. But I've heard about reachability in the context of these tools. And so how does reachability play into this versus SAST, DAST, and then IAST and RASP as categories?
So reachability analysis is what you want to do if you think there's a vulnerability and you want to try to determine if it's exploitable, right? So there's layers of this, right? If you get a static finding, you think there's a vulnerability, but you're not really sure if it's exploitable, right? It happens with library vulnerabilities all the time, right? So you've got some open source library, you're using it, but you don't even know, it's in the project, but you don't even know if that code ever runs. And so there's layers of this. And I would say reachability is the first layer of the analysis. It means it's theoretically reachable code. Doesn't mean it actually runs. It just means it's in some part of the control flow, if God knows what happens, that code could possibly run. We try to focus on what code actually runs. And so using runtime security, you can watch the application run. We record exactly what libraries are actually used. We record what classes are loaded out of those libraries, and we report that back to you. Turns out only 62%, well, actually only, 62% of libraries never load. That code never runs. Only 38% of libraries ever even load into memory. And so that other 62%, it's not really very risky. You can come up with some crazy scenarios to think about why it might be, but generally they involve another vulnerability. And then we focus in on just the code from those libraries that run. When you look at that, people always say like, well, 80% of applications are open source. That's super misleading. That iceberg is actually upside down. If you just look at the code that runs, 2/3 of applications are custom code and 1/3 is open source code. So just if you're focusing your efforts, like keep that in mind. Don't just prioritize library security and think you're done. That would be insane.
So when you think about these types of technologies, I'm curious from your perspective, what are RASP and IAST not good at? Or are they a panacea? They can do everything that I need in my AppSec program.
Well, I think they're your first best option for doing security testing with IAST and for runtime protection, RASP. I think you should have those in your stack. That's the way you're going to get the biggest bang for the buck. I think runtime library analysis is also really interesting, but when you're looking at libraries at runtime, they're not really structured the way they are in a manifest. So it actually does help to look at a manifest so you can see which the top level dependencies are and which the transitive dependencies are, because generally you can only update the root dependencies. So that's a view that we get statically. And I'm not, I think it's, as a CISO or an AppSec program lead, you have to place some bets. And you got to try to look for things that are the biggest bang for the buck. And that's where I think this runtime security approach to application security really wins. But there are, there's corner cases. I wouldn't say you should, there's other parts of AppSec that are important. One thing I think you agree that's important is threat modeling. We're doing this runtime observability thing now to try to help organizations get their head around how their applications actually work. And I know if you've done threat models plenty of times, you know that one of the hardest things is gathering the data that you need in order to be effective at threat modeling. That's what this runtime approach can do. We call it runtime observability. And we can build a digital security blueprint of the security in your application so that's where you start the threat modeling process, is you can start then asking questions about that data. Hey, should this thing have access control on it? Hey, what about this connection out to the internet that we didn't know was there? Stuff like that. And there's other aspects to AppSec programs, like champions and training and so on that runtime security is relevant to, but it's not a replacement for.
Mm-hmm. Yeah, some of those other kind of programmatic pieces and whatnot. But yeah, when I think about being able to recommend one thing for use small startups as an example, because they're the ones that tend to not have the ability to support 17 tools in a pipeline.
Well, everybody's in that boat today. Given the macro economy, everyone's looking at consolidating and coming up with a great minimal set of tools for their AppSec program.
Yeah. For me, RASP was really that answer. That was, I used a SAST tool because I happened to be working in Ruby on Rails. Brakeman was a available open source version of it that we could integrate. Right. And we got SCA through NPM audit and bundler audit in Ruby, like some of the free tools. But RASP was the one thing that I saw as providing the best gateway for what I was trying to do for the minimal amount of cost. And so that was,
it's interesting that most people don't see that the production protection piece and the shift left build it secure piece actually overlap. And I think most organizations ought to do both. Like, you should do your best to build secure code and also do runtime protection. But if you were perfect at either one of those things, you wouldn't need the other one. If you had perfect runtime protection, you could write whatever code you want and it would just be secure. I think that's not a great strategy. I think balancing those two things is the right strategy. So that's where I come down. But it's interesting that you went right to that.
Yeah, and that's one of the things, one of the dangers I've heard thrown around that organizations could face with RASP is it could become a bit too much of a security blanket. Well, we've got the RASP. Okay, you haven't. I'm curious now because you've talked to lots of different companies that are doing this, and this is one of those things that it was something that somebody threw out, but there was not really data to back it up. It was like, we could see that could happen. But in your experience, what do you see in that area?
I've never even heard developers say that, like, oh, we have, RASP in place, so we don't have to worry about this SQL injection that the tool just reported. They're really kind of separate initiatives with separate metrics. At this point, way back in the dark ages, I think some development teams were like, well, we got a WAF, we don't have to worry about secure coding. But that was foolish then, and it's foolish now. Like, nobody does that.
Yeah. All right. Anything else that we need to know about RASP and IAST and runtime security that we haven't kind of found our way into?
No, I think this is a great overview. I'm happy to dive in deeper with folks that are interested. But I do feel like most organizations should be thinking about moving to IAST and RASP as a solution rather than sort of the traditional approaches, SAST, DAST, and web app firewall, because those things just don't give enough assurance, particularly in modern environments. APIs security is a great example. It's really tough to get your APIs secured with SAST, DAST, and WAF because none of those things really works that well on complex interfaces. And a lot of the new API security products are really just DAST and WAF shoved together in a thing. And they don't really improve the security. But IAST and RASP work perfectly on APIs. In fact, most of the applications we secure are composed of APIs on the server side. We've been doing it for 8 years now.
Mm-hmm. Do you ever see RASP moving outside of the web? Like, what about RASP on an IoT device or something like that?
Yeah, you could. I mean, the real question is what is the policy that you want to enforce? Those trust boundaries, what rules do you want to put in there? You can use RASP to enforce just about any policy you want. We focus on web apps and web APIs because that's where the most risk is today.
Yeah.
But
yeah, the technology, I guess, the concept can be applied to anywhere, any place you're taking untrusted data from potentially untrustworthy users. The concept
and,
is
it's
there.
not all just untrusted data, although most attacks come in that form. There's other things like weak encryption and things that, vulnerabilities that aren't really data related, that even lack of security headers on HTTP responses, like IAST and RASP can detect and protect against those kinds of things as well.
It's funny that those were the only things the DAST tools I tested would give me was like lack of security headers. I'm like, really? I already knew that. I already knew what my security headers were set to. So,
yeah, right.
All right, Robert, take us into the lightning round. Robert has become the lightning round guy. For somehow, I don't know how I've
somehow or another
that, but there you go. Let's take us into these lightning round questions.
Okay, very good. So Jeff, what's your most controversial opinion on application security, and why do you hold that view?
Boy, I've stepped in so many landmines. I just got to pick one. All right, I'll throw one out there because I know Chris likes to throw bombs. I'll say that maintaining an AppSec backlog and ASPM in general is an anti-pattern. It's a symptom of a broken AppSec process that's generating more vulnerabilities than it's fixing. And you'll never fix it by dumping all those in a big dumpster somewhere and then periodically trying to sort through and groom and select and build into sprints and refix and retest. You've got to fix the vulnerability flow problem. You got to get your flow reduced and your fix rate increased. Otherwise, you're never going to get healthy. Why do I say that? Because I see it in every organization. It just doesn't work. It's like a way of kicking the can down the road. And, companies that I fully believe companies that want to be competitive, the ones that want to dominate in their sector, are going to be the ones that are best at both IT and security as part of that.
Okay.
So, yep, I'll throw that out there. We'll see what the listeners think.
Good. Next is what would it say if you could display a single message on a billboard at RSA or Black Hat conference?
Actually, I get asked that a lot at my company, but I think if it was me in charge of marketing, what it would say is build runtime security into your stack. It should just be there in your stack automatically, so that new applications you build are automatically instantly reporting vulnerabilities. They're instantly reporting libraries. They're generating SBOMs automatically. You have observability into how they work. And in production, they're protected against attacks. It's just a way simpler way, a very scalable way of thinking about security. In fact, it's zero trust architecture at the application layer, because now the security goes with the workloads. Wherever they go, they stay secure. You can move a container that has IAST and RASP installed in it. You can move it from your internal data center into the cloud, and the protection goes with it. It'll keep working no matter where you go. So it's radically simpler and more scalable. And so that's why I say build it into your stack. Runtime security, build it into your stack.
Okay.
Don't deploy without it if you're MX oriented.
Love that. What's your top book recommendation for those interested in security, and why do you find it valuable?
Oh man, I just forgot the name of the book I'm reading. It's by John Vielander, who used to be a fantastic OWASP contributor for many years. And I want to say his book is called Insider. But it's a great beach read. It's, hold on, I'm looking it up here real quick. Yeah, it's called Identified, not Insider. Identified. Okay. And great story about, well, I won't give the plot away, but there's lots of great hacking in the book that they talk about, how this team is sort of fighting against the government. And so far, it's been a great read.
Very cool.
Yeah, very cool. So, Jeff, we always like to end with a key takeaway or a call to action for our audience. So what do you want the audience to do as a result of this conversation?
Yeah, check out Runtime Security. I'd be happy to walk through it with folks, or you can do some reading. It's not like I haven't been writing and publishing for the last 8 years. So there's a lot of stuff out there, but learn about Runtime Security. It's really, it's a cool technology. And I'd love to explain that part to you, but it's also really a foundation for a different kind of AppSec program. And that's where it gets really interesting to me, is that we're seeing organizations that are actually getting healthy and getting functional at application security with really concrete results. And I haven't seen that in the industry over the last 20 years. Companies trying to use traditional tools, they just don't get there. They can't achieve escape velocity and actually make progress on AppSec. So that's the takeaway. Just check it out. Give it a shot. See if it's applicable to your enterprise.
Very cool.
And you can play around it. I have an open source project called Jot, which is interesting. If you want to play around with it, you're a technical person. If you're a pen tester or a threat modeler, like Jot might really be interesting if you want to ask questions about what's going on in your code base and get visibility back about it. Jot is really a fun way to learn about observability and instrumentation and security.
Very cool. Jeff, thanks once again for visiting the Application Security Podcast, helping me to work through some questions about IAST and RASP as well.
Appreciate it.
Yeah, and we'll definitely do this again. We'll see you on the conference circuit somewhere in the next number of months, and we'll do this again in the future to dive into another topic. So thanks for being with us.
Sounds good. Love the podcast.